Welcome to the March 2023 meetup. Hope everyone is excited for an excellent talk. Before we dive in, what we always do, first thing, jobs. If you have a job you're looking to hire for, jump into the NYHackR meetup in the nyhackr.slack.com, and there's a link for it at nyhackr.org. There is a jobs channel. It's called jobs-postings, or roughly that, some version of those plurals. And you can post your jobs there. So if you're looking to hire someone, go to job-postings at the NYHackR Slack. If you're looking to get hired, go to that same link and see who's posting. I know we just had something posted the other day. There's a few posted each week. Look for cool jobs or add jobs to it. I myself am always looking for shiny developers, Linux experts, and salespeople. So find me if you're looking to hire. I can talk about it here at the meetup. I don't have to post it. Well, I do post it, but luckily I'm on the screen. For those of you who are not on screen, hop over to the Slack channel and post your job. We'll put a link to that in the chat in a little bit. As always, we have pizza at this meetup. So let's see what I got today. Today, I got into a place called Antimo's. It's been sitting in my house for about 10 minutes, so the cheese lock is already solidified. Not a lot of oil dripping. We look at the backside. We see some decent charring. You can tell it's made in a gas deck oven. And I'm looking forward to eating this. So one day we'll have pizza in person together again, and I'll be very excited to see when we can all eat together. In the meantime, let me know where you got your pizza or other food from for this meetup. Let me know where you got it from. Let me know where you're eating, if you made it yourself, or if you got it from some awesome place near you. I know we have people coming in from all over, so send us a message, let us know. Also, besides this Zoom chat, you could also go on the NYHackR Slack and chat in the monthly meetup chat is the name of the channel. It's called monthly-meetup-chat. You can go in there to ask questions of our speaker. You go in there to talk about your food you're eating. Let us know. Before we get started, before we do a few more announcements, I would like to introduce Hanaro, coming to us from the UT Austin McComb School of Business. They are sponsoring this meetup, so we're back in person. They will be providing the pizza, and they would like to tell us a little bit about their program they have running right now. So I'll let Hanaro go ahead and tell us about UT's analytics program at the School of Business.
All right. Well, thank you for giving me this space. And what I would like to talk about today is about our MSBA program for working professionals. And what this program is about is a version of our full-time MSBA program, but stretched in time so that it allows people to keep their jobs while they can take the MSBA program. So before getting into any more details, I will tell you what is the MSBA program. The MSBA is a Master of Science program in which we combine business analytics, machine learning, AI, statistics, optimization, with business knowledge. And what we do is we teach students to leverage data science and analytics, data science, to quantify business trade-offs. So we have a focus on business, but we have a quant focus on business. For example, if you go into a straight data science programs, you learn the stats, DML, AI, optimization, and the like. That's cool. If you go to an MBA program in our school, we're going to talk about business trade-offs. What happens if you segment the market this or that way? What happens if you increase the price, and so on. In this program, we joined both domains. And what we do is we still teach our students the data science part, and then we ask our students to apply it to quantify, not to explain and quantify the trade-offs. For example, we're not just going to give you a trivial example. We're not just going to say, well, if price increases, then demand is going to go down. Well, we need to figure out by how much. And then what happens to your demand after that? Where is it going? Is it going to your competitor? Is it going to your other products? Then after that, what are you going to do to your inventories in the distribution chain? The distribution channels, how are you going to affect the capacity of your production facilities and supply chain contracts and the like? So we take a business view of the problem, but we teach our students to leverage ML, AI, stats, and optimization. So we train our students to go end-to-end in an analytics project. That means we train our students to create their own data sets. That means dealing with the IT infrastructure of the firm, distributed processing systems, the cloud, all of that stuff. Call the data that you need, then execute algorithms, maybe be part of a larger analytics team with other data science specialists, and then take it back to the business. Explain your solutions in business terms and sell business solutions to basically the people responsible for the business silos. So that's what we call end-to-end. This is a 23-month program. And what we have done is we have gone through a great length to separate what is best learned from a video, and we have created that video. For example, some of the technical content is better conveyed through a video because you can listen, then you can rewind and listen again until you understand it perfectly, do an example, and so on. So that can be done asynchronously and online, but then we meet, for example, in this case, on Tuesday afternoons and Tuesday evenings. And what we do is we have a face-to-face session through Zoom, a live session with Zoom, giving our students the opportunity to interact with the instructors, to ask questions, and get into the details, into the gray areas of the business questions that we are trying to address. So it's a combination of asynchronous learning combined with synchronous live learning, and that all of that takes place over a period of 23 months. We have stretched the content. Our full-time program is 10 months long. What we are doing is we are delivering the same material with the same level of rigor. So we cannot expect you to have a full-time job and take this program in the same amount of time. What we are doing is we're stretching the time to 23 months. In essence, in a nutshell, I think that's the description of the program. Gerald, I think I have already exhausted the time that you have given me. I don't want to abuse the opportunity, but I will be glad to send you more information or to address any questions that you may have for this program. We still have one more admission deadline later in April for the first class of the MSBA programs for working professionals.
Great. Thank you for being here. I know you shared your email address, so Nicole will put that in the chat and we'll send it to people here. For more people who want more information, please feel free to email him. And we also have a link on the meetup description, not to your email address, but to your program. So that'll go out to all that. It's already gone out to all the users, and we'll make sure that goes into follow-up. They'll link to the program, and your email will keep to the group. There's this group that's actually here. That way you're not getting 15,000 people with your email address. But yeah, so hopefully we'll get at this group. And if anyone has any more questions, the link is in the webinar chat, and we will post his email in there as well. So thank you very much for being here, and everyone who's interested in this program, go check it out. And if you want more information, email. Thank you. And
Thank you.
Very welcome. Very welcome. Speaking, I mentioned just very in passing there, 15,000 members. We're about to hit 15,000. We're 14.6 right now. So it's very nice to see this group grow from 20 people back in 2009 to almost 15,000 now. So it's very exciting for this group. And folks, when we hit 15,000, I'm sure we'll send out an email blast and we'll find some way to celebrate. How we're going to celebrate, I don't know. We'll find something. I'm not sure what we're going to do. So I'm looking forward to that day, folks. There's a big milestone when we hit 10, we're hitting 15 now, and hopefully we'll just keep growing with more interesting people. So part of this meetup group and how it has expanded, it's expanded into other events and workshops we put on in conferences. And we just announced yesterday the 2023 New York R Conference will be July 11th through 14th. We have workshops. We're doing 2 days of workshops this year, July 11th and 12th. The actual conference itself, the 13th and 14th. We have a few speakers up on the site right now, about a quarter of them, maybe a little more, and we have more and more being announced very soon. We're just waiting for people to confirm. You'll see who's already there. We have workshops from Max Kuhn and Rob Heinemann. We have speakers like Asama Toomey and Wes McKinney. It's a really great lineup. And those of you who've been to the conference before, you know how much fun it is, you know how much you learn. We're really looking forward to that. When you want to learn more, you go to rstats.ai. You just go there, you'll see all the conferences, but you can go to specifically rstats.ai/NYR. And if you want to get tickets, you could go to the tickets page and put in code NYHackR for a 20% discount. We'll be sending out an email blast to the whole group, but I was excited to announce it today. And at the end of the talk today, before the Q&A, we will give away a free ticket, either in person or virtual, for NYR. People have both options. So very excited to announce that. We will also be announcing in the next month or two this year's RGov, which will be taking place in October. A little change from the normal November-December timeframe. It'll be in October. More information to follow about RGov. If you can't wait until October for RGov, but you've already gone to NYR in July, we're putting on a general purpose data conference called D4, taking place in Tampa, August 23rd through 25th. We're excited for that. It's our first general data, not just programming or statistics. It's a little mishmash of everything. If you want to learn more about that, you can go to d4con.io. And again, the discount code is good for there too. NYHackR will get you 20% off of that conference. And we will also give away a ticket for that, either virtual or in person, after the talk, but before the Q&A. For the next few months, we have more meetups planned, but we need your help. We do it in person when we can. Well, we do a hybrid in person and virtual when we can, and virtual only when the situation arises. In April, we are looking for a venue to host us in New York City. So if you have space and you want to host a meetup, send me a message. You can find me at jaredlander.com. You can find me at landeranalytics.com. You can find me on LinkedIn. You can find me on Twitter. You can find me on GitHub if you need to. All right, find me anywhere. We're looking for a space for April to host the meetup. We have a space lined up for May, so we're good for that, but we need spaces every month. So if you want to do it as a one-off, you want to do it consistently or a few times a year, let me know. Be in touch. We'd love to have you participate in the meetup in that way. And one last thing, if you have questions for our speaker, since you obviously can't ask on screen, ask either in the Zoom chat or preferably in the meetup Slack. Go to the NYHackR Slack, go to the monthly meetup chat channel and ask questions there. And at the end, I will collate and ask our speaker your questions. So hope everyone has enjoyed their pizza and is ready to learn a lot. Our next speaker, I helped teach him R and now uses Python. So I chased him away. But I'm very excited to have him. I've known him for, I'm looking at the year, 12 years, 11 years, roughly that kind of basic math, right? Been a very long time. He's spoken at our conference before, and I'm very excited to have him speak at our meetup about this really awesome Python package he's put together, which he'll show you how to use from with an R or without R if you want. Everyone, please give a very good emoji welcome to Niels.
Thanks, Jared. It feels kind of like a little bit of a homecoming here. I I'll share a little bit of this in a second, but yeah, I'll basically talk about how to use Pandera in R using Reticulate. That's kind of the topic for today. And I was actually anticipating having a whole section on sort of gotchas and things that you have to be careful about, but based on the things that I tried testing out, like things just work. So, kudos to the Reticulate maintainers and authors. It's yeah, things just kind of work out of the box. So, kind of rare in software, I would say. So who am I? Right now, I'm the chief ML engineer at Union AI. Union AI is a company that essentially builds tools for data and machine learning. And we have a certain opinion on this. Basically, we built this platform called Flight. I'm not sure if anyone's heard of it. We're still kind of working on our marketing there. But Flight is a Kubernetes native workflow orchestrator. So think, Airflow or Prefect. That this is in Python land. I guess targets would be somewhat of a kind of pipelining language that I can think of in R off the top of my head. But I'm also the author of Pandera and Union ML. These are both Python packages that I've been working on for the past few years. Pandera more so than Union ML. That was, I think, released last year. But my background is in biology and public health with a little bit of, dance minor there sprinkled in from college. And I kind of stumbled into data science, machine learning, and programming. As Jared mentioned, my time in grad school doing public health was kind of the first time I dabbled in programming, and I sort of fell in love with it. And yeah, well, here I am today. My first language was technically Java in college, but that was like a semester, so I don't remember too much of it. When I kind of picked up programming, later on, I learned Python and R in parallel. So it was a little bit confusing at first, but I think it sort of helped just teach me about both languages. And, I haven't used R in a while, admittedly, but there was a time that I did kind of use it every day for, Shiny and dplyr and all that the good tidyverse stuff. All right, so I'm going to break this talk up into two sections. The first section, I'll kind of give you a Pandera crash course in pure Python. I'll introduce you to some of the core concepts in Pandera, which include schemas, checks, check constraints, and essentially give you a mental model of how Pandera works kind of in its native language, how people tend to use it, what it's meant for, what it's not meant for. And the second part of the talk, I'll switch over to using Reticulate and kind of showing you how to use Pandera with R. So without further ado, I'm going to go to this try Pandera link. This is actually in the repo's documentation. So if you go to Pandera, oops, really big. Yeah, if you go to pandera.readthedocs.io, there's a little tab here called Try Pandera, and it'll take you essentially to a Jupyter notebook powered by Jupyter Lite. And so this is a kind of in-browser experience for Jupyter notebooks. Okay, so what is Pandera? It's an open source framework. And you basically, with it, you can define schemas for data frame-like objects and integrate them into your pipelines. Really, the main value of Pandera is articulated. Maybe I can articulate it through why I built it in the first place. So at a prior job, I was just working with data frames all the time. So I do a SQL query, I would cache the result somewhere, and I would start hacking away at it, cleaning it up, typically for some kind of modeling purpose. So I would get bitten many times about bitten many times with data frames that had types that I didn't expect them to be. So I expected a column to be a date time and it was a string. Or I expected certain values to be in my numeric column and not others, right? So like positive numbers, and there would be a negative number in there. And I wouldn't catch it until later. So at least in pandas, right, you have this very flexible, powerful, mutable data frame object, and you can pretty much do anything with it within the bounds of the DSL. So this happened so many times that I kind of got sick of it and decided to write Pandera. And as you'll see later, the kind of the design decision for the way you write schemas is very much reminiscent of how you would write a pandas data frame. And it's also fairly readable. So the first thing we'll look at is how to define a schema. There are actually two flavors of how to define a schema. The thing I'm going to show you now is the second flavor. And I'm not sure who here is kind of bilingual in R and Python, but data classes and Pydantic are all the craze these days, at least in Python. So this is how you would define a Pandera schema using what I'll call the class-based method. So what I'm doing here is I'm inheriting from this class called DataFrame model, and I'm defining this class called schema. And it has two attributes, item and price. And as you can see here, it's just very transparent about what's supposed to be in this data frame, right? So item is a string. It has two allowable values, apple and orange. And when I call schema.validate, which is the main function, main method by which you validate data, what coerce equals true is going to do is it's going to try to coerce the incoming data frame into the specified types here. So it's going to try to coerce whatever the item column happens to be into a string, and it's going to try to coerce whatever price happens to be into a float. And so the kind of words for this would be parsing and validation, right? So parsing takes raw data, transforms it into in some way into some kind of like desired format, data type, form more generally. And so that's what, in combination with the type specified here, coerce equals true will attempt to do this type coercion. So that's a parsing bit. The validation part is essentially is here's my data, do a fancy assertion or do an assertion on it. You don't transform it. You basically just say these are the properties. Let me know if one of those properties has been violated. So what we're saying here is price needs to be positive, and the item needs to be in this finite set of things. Okay, so we've defined a schema. How do we actually use this in kind of like a real world pipeline? Well, there's a syntax here that may not be familiar to everyone, but this is basically the type hinting syntax in Python. So this came out in Python 3.6 or 3.7. But essentially, you can state what the types are of the inputs and outputs of a function. And what Pandera gives you is this decorator called check types. And we'll go over what lazy equals true is in a second. But basically, what I'm saying is I'm declaring a transform data function. It takes in a data frame. Don't worry about the syntax too much. This is basically like a pandas data frame, the Pandera version of it. And this essentially says the data frame that's incoming to this function needs to conform to the schema that we defined up here. Without the check types decorator, this is simply a type hint. So in Python, this won't do anything at runtime. It will simply it won't do anything. it'll only do something called static type linting, kind of using tools like MyPy, static type linters. It will try to statically analyze your code and see whether, the inputs that you're invoking transform data with are of the correct type. So this isn't super relevant for us because we actually want to do runtime validation. So with the check types decorator, we can see actually that this function does nothing, right? So let's go ahead and define it. And now I'm going to just define some valid data. So just the data frame of 2 rows. First item is an apple, like 50 cents. The second item is an orange, 75 cents. Not sure how much these go for these days. But if we pass this into transform data, it doesn't really do anything, right? Because transform data returns nothing. But under the hood, actually, Pandera has called schema.validate on the data frame even before this function body has started executing. So to show you what this looks like with invalid data, I'm going to introduce some corrupt data here. So here's a typo on the apple item, and then there's just like some crazy negative value here for the price. And so what's happening here is I'm doing a try except. So I'm going to try executing this function. And if I find a schema errors exception, I'm going to catch it, and I'm going to display the failure cases. And this is really how many people that I've seen and code that I've stalked various repos that use Pandera, and just to get a sense of how people are using it. And this is one of the core things, the core ways of interacting with Pandera is it basically allows you to add kind of guardrails around your functions, or if you have a long pipeline of functions, right, you can add a guardrail at the input of that pipeline, the first step, and then it does a bunch of stuff. You might not want to type check everything at every intermediate step, but then at the end of your pipeline, say you're writing to a database, before you write, you want to make sure certain things are, certain properties are true. And so this is one of the core mechanisms by which you can add these guardrails. And essentially, if one of those properties has been violated, in this case, 2 properties, with the lazy equals true argument up here in check types, what it's going to do is it's going to try applying all the validation checks that we've defined. So to go back up here, first it's going to coerce the types, and it would throw an error if the raw values are not coercible. But it's going to apply this check and this check. And in this case, there are errors in both checks, right? And it's going to report all the checks possible. If lazy equals false, this would raise a schema error, which is a different error type, and it'll just raise as early as possible as soon as it hits the first property violation. So as you can see here, this schema errors exception contains a failure cases attribute. And this failure cases attribute, Pandera takes a lot of care trying to pick out where exactly the error occurred. So in this case, if we look at this invalid data frame, right? It's on the 0th and the 1st index, and we can see here that this matches. So this is useful if you have, say a small to medium data set, kind of like fits in a pandas data frame, fits in memory, and you want to know exactly where every single failure case occurred. Another way you can use schemas is you can simply invoke it inline. So, say you have a function here, this schema.validate call is essentially equivalent to if I got rid of this and this and I did this. So schema.validate returns the valid data if all the checks passed, and then raises an exception if the checks did not pass. So that's kind of like the kind of programming model of Pandera. A lot of, at least in Python, a lot of data validation tools, their purpose is to collect a validation report. And so they focus a lot on very nice kind of informative kind of HTML documents and other kind of artifacts. Pandera is really kind of a developer tool where, you know, it's up to you what you want to do with these failure cases, right? So this is the syntax for if I want to catch the failure cases, if I want to kind of like filter out, because I have the indexes, right? I can like filter out all the invalid data and then produce a kind of a valid data frame under the schema. So it's really up to the data scientist or the MLE or the data engineer to figure out what they want to do with this. And Pandera doesn't do too much by way of coming up with kind of like aesthetic reports. Okay, so the next part is about thinking about schemas as data quality checkpoints. This is what I mentioned earlier, right, with the pipeline. You don't want to necessarily validate everything. There is a runtime cost to this, since you are executing code that is essentially a fancy assertion. But here's another kind of mental model for you to kind of chew on. So here's just a redefinition of the schema we're already familiar with. With Pandera, with this particular class-based syntax, you can actually inherit from the schema and define a new transform schema. And it's going to inherit all of the properties of the original, the parent schema. But you can express additional, this is like the additive nature of inheritance, where you can add additional attributes to this transform schema. And this kind of gives you, the reader or maintainer of like a data pipeline, a sense of, okay, there's a function somewhere, that's actually below here, but there's a function in the abstract that will take this as input and produce this as output. And you can immediately see just visually in your code base, okay, the input has item and price, it's of these types, and then the function needs to add an expiry column to this of type timestamp and maybe some other properties. So as you can see on this page, this is the function. It's very simple. It just assigns a new column to the data frame. So if we run this, it seems to be happy. This is great, actually. So this isn't actually doing the runtime checks, right? But if I say have a bug in my code, this is a toy example, obviously. I just have a typo here. But you can imagine, you know, a more complex beast of a pipeline, more complex functions. So here, what I'm doing is I'm adding the check types decorator again. So this will runtime check this input, and then also runtime check the output of the function. And if I run this, right, the error is a lot kind of more alarming if I don't do the try except. Right, it's like going to throw this error. But just for the purposes of this presentation, I'm doing the try except pattern. And we can see here, Pandera complains the check was column and data frame. And the failure case is, oh, this is actually a bug. This should be this thing. Okay, I'll need to file an issue for this. But this is saying this is saying actually the expiry column was expected, but there was a bug in there's a typo in there. So essentially, what this gives you is a function that just always checks the data, and in a lot of cases where there isn't such a big runtime cost, say it's a data frame of a couple thousand rows, even tens of thousands, this shouldn't take too long, and you can be kind of safe that under the assumptions of your schema that the data you're passing in is correct. So just to give you a little bonus, the object-based API, this is the API that was the original API for Pandera. Schema is this class-based syntax is essentially a like syntactic sugar. This thing will essentially, compile down to a data frame schema object. So just to show you that, this is the class. If you call toSchema, it's going to convert this into a data frame schema object. And so this is actually the thing that does a lot of the heavy lifting. It's the original specification. The reason you might want to use the object-based API instead of the class-based one is you can apply imperative logic to it. So you can say schema.add columns, right? So this is equivalent to the transform schema thing, right? Whereas this syntax is simply additive. You can't, once you inherit from schemas, you can't really remove properties without some hacking. Whereas the object-based API, it's very natural. You can add columns, you can remove columns, you can update the properties, in this case of the price, into an integer. And you can similarly call schema.validate on this as well. Okay, so I hope that was informative. Give you a sense of how Pandera looks in Python. And here are a bunch of features. It's fairly feature rich at this point. It supports regex pattern matching for columns. So you don't have to, you have a data frame of 1,000 columns that named similarly, right? So call _1, call _2. You can define a single column schema component and apply that by saying regex equals true. So there's a bunch of different stuff, and I'll actually show you in the next part. I'll hop back onto the Quarto slides. Sorry, how am I doing in time?
You're still good.
Okay.
Good time.
Awesome. Okay. So next part of the talk is Pandera with R. And this was an interesting, adventure. I kind of had to ramp up my VS Code editor to use R, just kind of as an extra challenge. I hadn't used RStudio in a while, and I just wanted to see how the VS Code support was. So that was fun. So with Reticulate, all of this, by the way, is written in Quarto, and at the end I'll show you where the repo is. And I'm using a Conda environment just because it's easier to manage both R and Python dependencies. But before moving forward, I did want to make this call out. The kind of subtitle of this talk is something about a highly unnecessary but interesting case study in R Python interoperability. So it's highly unnecessary because there are actually R packages that do data validation already. So, there's the validate package, which I think has been around for a while. There's point blank. So there are probably others, but these two have been in my radar for a while. And actually, I kind of took inspiration from these two when I built Pandera maybe 4 or 5 years ago. So just a shout out to the authors and maintainers here. The syntax is quite nice. So, and it integrates nicely with kind of the dplyr and the R ecosystem. But, if one can do something, it's worth trying. So here we are. We're basically going to define a Pandera schema in a Python runtime. And with Reticulate and Quarto, you essentially have access to these objects. So here's the schema you're familiar with, apples and oranges and prices. And here's some Python data that we're going to test out. Here's some R data. So we're defining a data frame, same thing. Items and the price associated with each one. So this is cool. I thought there would be some like NaN issues here, but somehow they were all handled. So this pi, I don't know what to call it, object, I'm just going to say. My R is a little rusty, so if you see R code here that looks weird or not idiomatic, please please pardon the weird looking R code. So okay, you have this pi object, and you can essentially access a bunch of attributes that are defined back here, right? So we define schema in Python data. So I'm going to straight up, try to validate the Python data and use the schema in the R runtime. And, you can see that works. And our data frames, right? So this guy right here, our data, we're going to feed it into the schema validate method in Python. And I actually still need to read more about this, but from my understanding, what is happening here is there is a Python subprocess or runtime embedded in the R, runtime. And what Reticulate is doing is it knows how to serialize and deserialize certain objects, functions, classes to and from R in Python. So what's happening here is the R data is being converted into a pandas data frame. And then this is just the Python. This is the Python schema class. This is the class's validate method. And it's essentially validating the pandas data frame, giving back the result, and then converting that back into an R data frame. And that's what's being printed out here. So what if the data is invalid? It took me a little time to kind of figure out how to do this, but here's some invalid data. Here's a typo in orange, and here's a negative value. So we should expect this to complain. Let me know if this is super, heretical or not, but I use the try catch, construct here. I'm trying to validate the invalid data. I'm saying lazy equals true because, I wanted to apply as many checks as it can before raising the error. And then Reticulate has this nice last error function that will return like an R object that contains a bunch of stuff. And in that stuff is an exception attribute that I'm grabbing here. Actually, a question for everyone here is I'm not quite sure what the difference between an attribute access with a $sign is versus this adder function, but this is how I got it to work. And then this gives me the Python schema errors exception. And I'm going to make this available in the global scope. So I know this is going to fail. And here are a few, this is kind of the only gotcha that I had with this, and this is well known of 0 versus 1 base indexing. So if you recall back in Python land, let's go back up to this exception, right? So this failure cases data frame provides the index, and it's 0 indexing, right? So when I get the failure cases here, so this is exception, this is exactly the same thing, exception $, failure cases. First of all, the row names in a R data frame, I had to remind myself they're strings. So first, I need to +1 all of the indexes and convert it into characters to get the failed row kind of identifiers for this. And I'm just printing out the failure cases here just to prove to you that it contains the right failure cases. And one use case of this would be to filter out invalid rows, right? So unfortunately, this, there is no like utility function for this. This would probably be, something you have in your library if you choose to, be crazy and use Pandera in your R pipelines or your scripts or notebooks. But one use case is, okay, we have the failed rows. So I'm just going to filter out the invalid data and produce a filtered data data frame. And so we're left with one item here that's valid. Okay, the last thing I want to showcase here is synthesizing test data with Pandera. I think this is maybe the one thing that justifies using Pandera over, the R validation packages. I don't know, maybe there is a data synthesis library that I'm not aware of. So please do let me know. So with Pandera, you have a schema, and just as a background here, this was kind of like one of the most grueling coding experiences I've had. Kind of at the point of writing this feature, Pandera had a lot of features already, like a lot of constraints, a lot of checks, built-in checks, a lot of like different things here and there. And the idea behind this is, okay, we've already defined what valid data looks like. And I don't know about everyone here, but to test kind of like my data cleaning, data processing code, you need to write unit tests, you need to write test cases, and it just became such a pain to write mock pandas data frame, mock pandas data frame data to test the functions, right? So here's my valid data, here's the happy path, here are like all the things that can go wrong. And you want to test those cases. Well, the motivation behind this feature is exactly this, where, if you already know what valid data looks like, why can't we generate data from it? So you can test the happy path. And as I'll show you later, you can, create sort of a schema spec for something that you're fairly sure is guaranteed to fail your tests, right? So here's just like an example of this, where the schema class has an example method. You give it a size and it'll generate a data frame that's valid under the constraints of that schema. So you can see like you have ridiculously small prices for apples and oranges, but this is not realistic, but it'll test the boundaries of your function pretty well. So the way you might want to do this in R, right, is you have this process data function. Imagine this is in your source code. Takes in data, takes in another argument, and essentially what this function is doing is it's validating the data first. So the output of this will be, you get back an R data frame. And then we're just piping it through to mutate and adding a stock column. So a test for this function might look something like this. And here's the happy path, right? So we're using the schema itself. We're generating 5 rows of data as mock data. We're passing as just a single value in stock. So that'll kind of broadcast throughout the shape of the data. And you pass it the mock data, and you'll do some assertions here realistically, but here I'm just printing the output. So it's giving you some like reasonable looking prices. The items are correct, and the function did the correct thing. So this is maybe something you might want to add to the test. But as I mentioned earlier, right, we can, instead of handwriting multiple data frames, right, to test all the different edge cases, you can create an invalid schema class. And here we have the right columns and types, but it's not constrained by apples and oranges, and it's not constrained by greater than 0. So when we write our test process data error case, we're going to create some mock data from the invalid schema. We'll do the try catch thing again so we can get the exception, and so we can make assertions about the failure case. And here the failure case is, this is an empty string that occurred in the item column. And so I've yet to figure out how to do this actually in R, but the way you would do this in Python is actually this whole feature is backed by a library called Hypothesis. So this is a Python library that allows you to do property-based testing. So you essentially state the properties of your test, like these are the input types, these are the expected output types, and Hypothesis will generate just a bunch of data based on those properties. And the thing is configurable, but you can set it to say like generate 1,000 examples. And it's just going to, I think it's called fuzz testing. It's just going to test all sorts of different inputs to your function. And more often than not, actually, it'll find a lot of holes in your implementation. So this has been, Hypothesis has been a super helpful library, at least for me. So like the simplest way to do this in R would be to do a for loop and then to call this example method multiple times, and each time it'll generate a different data frame that is most likely invalid. Okay, so hopefully that kind of gives you a flavor both of Pandera and then, Reticulate if you hadn't used that before, and kind of like the magic that happens when you kind of pass Python objects into R objects into Python. So Pandera lets you define statistical types for your data frames, and statistical types is something I somewhat coined, hasn't caught on yet, but the idea is you have kind of types that are the regular kind of data types, right? Integers, floats, numbers, strings, dates, booleans. But statistical types are interesting because you can only really validate it by checking the values itself. So if you're saying this column is normally distributed with a mean of 5 and a standard deviation of 2.5, you can't really know that unless you check the value, right? So I didn't dive into this part of Pandera, but you can write kind of these hypothesis tests and kind of bake them into your schemas as well. Takeaway 2, you can use R, use it in R with Reticulate. And just something, if someone listening to this is curious, I'd be curious to see how this can break, and what certain gotchas are when either using Reticulate in general or trying to use Pandera in a R runtime. So I want to thank you for your time and attention. You can find me at Cosmic B-Boy on Twitter. The slides are up here on Union AI OSS Pandera NY-Hacker 2023-0330. The repo for Pandera is over here in the Union AI OSS org under Pandera. And there's a Discord channel here where you can join, ask questions, yeah. Thank you so much.
Thank you. I'll do an emoji clap for Niels. That's all we can do with this now. We can't do real applause anymore, so you get emoji claps. Well, thank you very much for the talk. I have a few questions to throw at you. In the early side, you showed like a do catch. Is it possible, like if you're putting the decorator on it, is that good enough and it will just fail out and you pass it invalid data and the function just generates an error, or what happens?
So you're talking about this, or wait, in Python, like this case?
Yeah, like a little lower. Like, so if you called that function without the try catch afterwards, what would happen? The whole function would create an error if you had one exception?
Yeah, exactly. So if we here's the, we'll call the decorated function with invalid data. And, the exception is like this, giant string that kind of tells you, okay, there are different kind of error reasons. And so there are two error reasons that occurred are schema component checks. So schema components would be like columns of a data frame or the index of a data frame. And this is like a summary. It's like it tells you what context the error happened in. So in this case, it was a column. It could be a data frame wide check as well. I didn't get into that. But yeah, the error is just thrown. And wherever this is running, it could be like in a cron job or somewhere in the cloud. And this will be the error message you see. However, you could do something like this where it's like, I want to report something a little richer. I can raise here if I choose to do so.
And or you could use the inline syntax and just so you could build that into your function to check.
Yeah, exactly. So it's pretty flexible that way.
Cool. We have another question. Could you elaborate on how the Python and R output objects interact with each other in a Quarto document?
Yeah. This was something I was learning about literally in preparation for this talk. So from my best understanding, so let me just kind of hop into the code for this slide deck. Here's my Quarto doc, and you basically, you're familiar probably with the syntax here. We have like these code braces or code fences, and you say which runtime you're using in that code fence. So from my best understanding, the Python code will run in that Python subprocess when you kind of like execute this Quarto document. And any object defined in the Python runtime is available via this. This is a reticulate thing. I'll just call it an object. I don't know what the terminology is actually, but you can access all of the things defined in that Python runtime in with the $ notation here. So to answer your question kind of maybe vaguely, essentially there are two processes occurring. There's the R and there's the Python process. And what Reticulate is doing is essentially when I'm executing R code that relies on the Python objects, when I do this, it essentially serializes, gives me like a representation of the Python object. And when I could, so essentially it gives me like access to the classes and functions and the methods, kind of like in this nested fashion. And I can either, this basically is all, from my understanding, is all occurring in Python in that runtime. So the Python schema.validate method is validating the Python data frame. Whereas here, what's happening is the Python schema.validate is being fed a R data frame. And what Reticulate is doing is it's converting that R data frame into a pandas data frame, applying that to the validate method, and gives me back the R data frame. And that's what is being printed out. I could be wrong there, though. I haven't tested this too much.
And there's a follow-up. In Python, can you do like $, or the equivalent of $sign in Python, like r.r_data in Python?
I believe so. I was looking at the Reticulate documentation. I think it's only available in like R Markdown or Quarto. So I think it is this. So if I do this, or yeah, there's some R object. We can look at the docs, but that is a possibility. So you can, use R functions as well in your Python code, which is ridiculously cool. Unfortunately, I think to do this in just a straight up Python module, that's not possible. I'm not sure if that's in the works, but like a kind of Reticulate Python package that allows you to do the other way around.
R2Py or something like that.
RPy2, yeah.
Yeah. And as from what I've seen, it doesn't work as nicely as Reticulate does. Yeah.
Yeah, it's a much like older, I suppose, package. I guess it is mature. Like I've seen there's a bunch of releases for it, but yeah, the syntax isn't as neat.
Okay. Before I did the giveaways, you had mentioned something about data frame checks, which goes with one of our questions here. Can it do checks like the number of columns in a data frame or the number of rows? Can it check for that?
Yeah, I really need to beef up kind of like the built-in checks here. The kind of the fallback for a lot of these things is custom checks, which I did not cover, but maybe I can do that here. So if you do pa.dataframe check, yeah, oops, what did it do? I can define a method here that check rows. So there's a bunch of code you have to write, but the short answer to the question is it is possible. I guess the focus and the reason for this is the focus of Pandera is to sort of feel more like like a SQL schema, right? It's like a SQL schema doesn't outright say how many columns and how many rows there are. It kind of gives you what the columns are and what the data types of the columns are, and then Pandera will add the additional checks stuff. So short answer, yes. Longer answer, I wish that was built in. So, we're taking contributions, Yeah.
Then in a similar regard, can it validate like the mean is of certain value around a delta? I'm going to guess it's a custom check too, where like the variance of a column is around a certain delta.
Yeah, the plan, the syntax for this. So the built-in checks are accessed via this thing. So there are a bunch of built-in checks, but the syntax would be like something like this that I want. But
Okay.
yes, so today you would write a regular check. So this applies to, let's say price. And you would get the series here. And so you would return series.mean and then, something like that.
And then it's all you need to do. What you would be done at that point. You don't need to go apply it. It just happens now.
Yeah, it just happens now. Yeah.
Okay. Cool.
The object-based schema has a different kind of thing. So, the discrepancy kind of bothers me, but it is what it is at this point. But at this, yeah, this would be like your check goes here, right? And the expected signature is either a Boolean series if it took a series in, or a data frame in, or a data frame Boolean. So
Okay.
Pandera will automatically know, okay, how to handle the output, and then massage it into a form that is human readable if the error does occur.
Okay. And since you did mention a SQL schema, can this validate like something you're using with like SQL Alchemy, like when you get the results back and it checks?
Yes, it can, provided that you're reading it into a Pandas data frame. The integration I'm working on right now is with IBIS, and so IBIS is I believe a Voltron Data, Wes McKinney and co project, and once that's done, Pandera will be able to do in-database validation. So you use the SQL engine to do the thing, and then not exactly sure how to report the errors. At this point, we'll have to figure that out. Probably it'll read it in as a Pandas data frame, or have it be customizable. A temporary table may make sense. I'm not sure. Yeah.
And since you brought up Voltron, what about arrow tables or polars?
Yes. Also, in there's an issue for these, and
Okay.
they're like there's a few interested parties. I guess the last thing I'll say about that is I did another kind of grueling experience, like internals rewrite of Pandera to be able to actually support additional backends. So the idea is, just to hop down here, the data frame schema becomes kind of like, so the problem before the rewrite was the data frame schema was both the specification for the constraints and the validation. It implemented the validation logic. So it kind of conflated those two concerns. And the rewrite kind of decoupled those so that you can have a generic data frame schema spec and then just arbitrary backends, assuming that the spec kind of conforms to whatever the data object is. So any kind of tabular thing, we'll rip that out and make it not a pandas data frame schema, but like a table schema or something of that sort. And then you'll be able to just write arbitrary backends for it, including polars and IBIS.
Yeah, that'd be really cool.
Yeah.
All right. So enough about things it can support. Let's ask about things you can define. Like, can you define that missing values are allowed or are not allowed?
That is here, nullable equals true.
Great.
Or false. Yeah. So there are a bunch of, so the column object has a bunch of built-in properties. So it takes in the data type, of course. These are a single check or a list of checks that are user defined. Nullable, unique. Essentially how to report duplicates. This is a Pandas specific thing, but it's kind of general enough to say I want to report every duplicate or just the first occurrence or something like that. You can say whether something is required. The name is interesting because the column can actually be used in isolation. You don't have to use it in a data frame schema. You can actually pass it a data frame and it'll only check the column through this name. So if this name is defined, it'll check that column. Regex equals true will consider the column name to be a regex pattern and then it'll apply that. And then title and description are kind of human readable kind of labels to attach to components of your schema.
Okay.
Yeah.
And then what if a column has multiple failures? So the example you showed, there's one failure in a column. No, let me take that back. That's not the question. Because just what if a row has two columns that failed their checks?
Yeah, so that's where the whole lazy thing comes in. So let's maybe go back to the invalid data. So by default, lazy is equals to false. And so what happens in this case is it's gonna raise the first error it sees just based on, it's purely based on like the order in which the columns are defined and the order in which checks are defined. And it happened to apply this is in apple orange check first, and it'll report that failure case. When lazy equals to true, oops. This is where the whole like try except thing comes in, but oh no, yeah, this thing. Essentially what happens is it'll try to apply all the checks and then it'll aggregate them all into a single data structure, which is failure cases, which is itself a data frame.
So they're like, you still only have two rows, but n failure cases would be greater than one.
Yes.
Okay.
Yeah.
All
So
right,
if this had 100 like the worst case scenario is every single value is invalid, in which case the failure cases data frame is actually in tidy form, right? So it's going to be not a great data frame to work with, especially if you have like 1 million rows, you have 1,000 columns. it'll be, a billion row failure case thing. So the failure case, the number of failure cases you report, that's also configurable. So you can say 5, and then it'll only report 5.
Okay. All right. You mentioned about it, adding overhead. How much overhead does this add? Because I know, like, there's always debate, like in R, like using assert that, like you're doing an if check essentially each time.
Yeah, exactly. That's on my to-do list is a benchmarking exercise. So I don't have concrete numbers, unfortunately. The main thing I will say is it's roughly based on what I've the kind of informal benchmarking I've done. It's roughly equivalent to if I had done this, like valid data dot item dot is in apple orange, and then I assert like all of these things are true. So it's roughly equivalent to what if I had written them by from scratch.
And then as a related question, I know there's an R package, like it does either validate or checkpoint, or maybe it might be a different one, that it does all the checks while you're developing. When it's actually time to run the code, it turns them all off to avoid the overhead. Is that a feature you have here?
That is an issue. Pandera hasn't had a config file for forever.
Okay.
But this would be like an environment variable or config file thing that you just like disable everything, and then none of the runtime checks happen.
Okay.
So yeah, it's in the works.
Cool. All right. And I think that was all the questions we had. You had a question about attributes versus dollar signs. So if you use like object $sign something, like let's say it's a data frame, it's data frame $sign column lets you access it. Whereas an attribute is sort of like a hidden thing about the object. And so like, let's say you had a list, you could do list $sign item in a list, whereas an attribute, it's not printed by default. It's not stored in a slot, and you can only access it. It's metadata about the object.
I see. Cool.
Yeah. Cool.
That clarifies it.
Great. All right. With that, we have all of our questions asked. And I'll say let's give another round of emoji applause to Niels for coming and giving this talk. Thank you very much for being here. The video will be up in a few days on the YouTube channel. And everyone, come in April. We need a space. Give a space for April and come see the speaker. Come to the conferences. Have a great time. Thank you, everyone, for being here. And again, thank you to Niels for giving this talk. And thank you, everyone. Hopefully, we'll see you again soon. Bye, everybody. Another round of applause.
Thanks so much, everyone.
Bye.
Bye.